Hello everyone, and we're now on lesson 8 in unit 2, which variable to solve for, part 1. All right. So we're going to go through this, and this first one kind of just starts out, and we have a parallelogram. So just as a real quick review as to what a parallelogram is, a little quick review of geometry. So a parallelogram, I'll just draw one up here for you. There's your parallelogram. Again, a parallelogram just means that it's a four-sided figure where the opposite sides are parallel to each other. And because they are parallel to each other, you can infer that they are the same lengths. All right? And if I were to want to find the area of a parallelogram, well, it's the base times its height. So we can say there goes base times height. So that's the root of what these are. Okay? So if we go through this, they start out and they say that the base is here, and there's the area. Okay, so let's just see if we can go and walk through this and see what's going on here. If I start at 1 and I end at 3, okay, I could have gotten there by adding 2, or I could have gotten there by multiplying by 3. Let's go and continue on. If I start at 2 and I end at 6, well, I could have added 4 this time, or I could have multiplied by 3 again. So as you see, the construct here is whenever you move this direction, you always move times 3. So the base times 3 gives you the area. There's the base, 3 times 3, and you get 9. And then thus, if you take 4.5 and you multiply by 3, you get 13.5. If you take 11 halves, or 5.5, if you will, and you multiply by 3, you get 16.5. Okay, great. Well, now, if I want to go backwards, though, all right, now, rather than multiply by 3, now I divide by 3. So 36 divided by 3 is 12. And same thing here, I'm going to divide by 3 since I'm going backwards. 46.5 divided by 3 is 15.5. So there's a direct relationship between there. And moving on to number 2. It says decide which equation could represent the relationship between B and A. Be prepared to explain your reasoning. Alright, well, we knew that if we took the base and we multiplied it by 3, that we'd get the area. Alright, well, that makes sense. So if you look at it, woo, it looks just like it right there. But now, this is solved for the area. What if I wanted to solve for the base? In other words, one of these down here. I've given you the area. I want to find the base. What did I have to do? Well, I just divided both sides by 3. And I get that equation, which is right there. So that's screwed up. You didn't take the base ever and divide it by 3. You didn't take the area and multiply by 3 to get the base. So those things are obviously out. So it's just B and Bravo and Delta, which are true here. Alright, next one, we're moving towards this little story here. And essentially we're having a parade, and you have a 2-mile stretch of land that you're trying to clean up. And they're just changing out as to how many volunteers you have. So if you want to find out, find the length of the road section for each volunteer. So I'm trying to find miles per volunteer. Okay, so I'm keeping the 2 miles the same each time. Okay, so for this first one, I'm having 2 miles divided by 8. Well, 2 divided by 8 is the same as 1 divided by 4. So each one is a quarter mile, or 0.25. 2 divided by 10, 2 miles divided by 10 volunteers. Well, that turns out to be 0.2 miles per volunteer. If you take 2 miles and divide by 25, now you get 0.08, or 0.08 miles per volunteer. And if you divide 2 miles by 36, and then you turn out with 0.5, and the 5 is repeating. Okay? So that's what's going on here. As you increase the number of volunteers, the number of miles per volunteer just keeps dropping. Okay? So what they do here, this is write an equation that would be easier to find L. Well, L equals 2, and of course that unit is miles, and N is volunteers. So this is what we've got here. Length, the equation that would usually to find L, the length of the road section in miles for each volunteer. All right, you have 2 divided by n. All right, you can also rearrange this thing, multiply both sides by n, cancels on this side, shows on the other, and that equals 2. You could also take this exact same thing here and solve for n, which would be 2 divided by L. So you have 3 versions of the exact same equation. Depends if you want to find out the length per volunteer, if you want to find the length that you're going to be cleaning up, or if you want to find the number of volunteers. All right? Find the number of volunteers in each group if each volunteer cleans up the section following lengths. Okay? So each one of these is miles per volunteer. So they didn't do a real spectacular job of labeling these, but this is what they're trying to get you to do. Okay? So what they're saying is, I'm giving you that L, and I want to find how many volunteers I'm going to need to go and get that miles per volunteer. So we can go and take this thing. Since we're trying to find the volunteers, this is find the number of volunteers. So I'm trying to find that right there. So I'm going to use this little last equation right here, 2 divided by the L, the miles per volunteer. So 2 divided by n, or n divided, is going to be this equation right here. Well, if you find out if you want 0.4 and you want to solve for that, it's going to be right here, 2 divided by 0.4, or 5 volunteers. For 2/7, you'll need 7 volunteers to get that one done. For 0.125 miles, 2 divided by that, you end up with 16 volunteers. And of course, if I have 2 miles and each person does 6/45, which is around, let's see, a tenth of a mile or so, you'll need 15 volunteers to get that much done. And then write an equation that would make it easy to find the number of volunteers. So that's the equation that we've been using this entire time. All right. I'm going to move on. We want to go and graph this equation. Okay. I'm giving you this equation right here. We want to go through and just like graph this thing. So what we can do is we can actually start putting in the x value. So you want to set up a little plot here of x's and y's. And let's go -2, -1, 0, 1, 2, 3. All right, when you notice here at 0, this is the unique one. If I have 0 down here, 2 divided by 0 is undefined. So it creates something called an asymptote right here. And if you go negative, as you get the negative numbers get closer to 0, this thing drops off very quickly. And the same thing here, when the number is really small, it goes to infinity and then kind of slowly comes back down this way. All right. So this is just a kind of a nice little way to look at this thing. What's the largest value that y could ever be? Positive infinity. And that's that thing right there. It's going up to positive infinity. What's the smallest could be? Negative infinity. All right. Filling and emptying tanks. Let's look at that one real quick. Okay, a tank initially contains 124 liters of water. When it's filled with more water at a constant rate of 9 liters per minute, how many liters in tank A after the following amounts of times have passed? Well, if you start with 124 and then you add 9 liters per minute and then you multiply it by the amount of time in T, and that equals your final volume. Okay, real simple. So if it's been 4 minutes, well, 124 plus 4 times 9, that's 124 plus 36, gives you 116. 80 seconds, well, I don't really like 80 seconds. And so what I can say is, I can either do a couple of different things. I can either convert this to minutes, or I could go and convert this liters to 9 liters for 60 seconds. I have 2 options. I prefer to go and convert this thing over to minutes. So what I want to do is take the 80 seconds, and I say, well, there's 60 seconds in 1 minute. that goes away, and so we end up with 4 divided by 3 minutes. 4 1/3. Alright? So you take that times 9, add the 124, and you get 136 liters. And in M minutes. Well, if the M is right here, that's your variable. So 9 times M, plus 124 equals the final volume that you'll have. Okay. Remember, this is always adding, so if it's adding, we're going to be doing a plus. Now in the second one, same idea, only now we're going to be removing, okay, how many minutes has passed when tank A contains the following. Alright, when we get down here to tank B, we're going to be draining. So we have this nice little equation here. You have 151 liters, and they want you to figure out the M here. It says how many minutes have passed. They want you to solve for M. So if you take this equation, alright, I'm going to have 9 times M plus 124 equals your final volume, right? I'll just do a V sub F, final volume. I'm solving for M. First I have to subtract off the 124 from each side, and that cancels. And then I'm going to divide by 9, and there I have M. So here's the equation that was written in here, alright, which is very close to what I've got. And all you have to do now is just substitute in. So if I want 151, that's 151 minus 124, and then that whole thing divided by 9, and you end up with 3 minutes. If you want 191.5 liters, it takes you 7.5 minutes. If you take 270.25 liters as your final volume, alright, and so that'll take an additional 8.75. Alright, now you'll notice what's happening here. What did we do a little bit differently here? Alright, we added a little bit. That was from how long it takes to get from here to here, right? And how long it gets from here to here. So that's just another 8.75 liters, okay? So this one is a little bit screwy. So what I like to do on that one, if you've got 270.25 minus 124 divided by 9, that's the way I would have interpreted it. But again, you can start with any initial volume that you want. Here I select 124 all the time, and here I decide to go and start with the previous one. Okay, so we'll do a little bit. You can answer that one either way you want. And of course, right here is your equation to, if you have whatever P liters, always starting at 124 is your original. Okay. And moving on. Number 3. Tank B, which initially has 80 liters of water, is being drained. Now if it's drained, I have to subtract. Alright? So if I'm going to be subtracting at a rate of 2.5 liters per minute, how many liters will remain after the following times? So what did they do? Well, we started at 80, and we're subtracting off 2.5 liters per minute, and 30 seconds is obviously 0.5 minutes. That way the units cancel. You do your math, and you get this many liters. 2.5 times 7 minutes, right? It's going to be 80 minus 15, so you get 65 liters. And of course, if it's just T, we can just put in the T there, and that's the final volume there that we're going to work with. Okay? So it's pretty straightforward. Number 4. This is how many minutes T has the water been draining when tank B contains the following amounts. So now they're giving you the initial and the final. So you're starting at 80, you're going to the final, right? So you have a change of 5. All right, it's very similar to this equation that you have up here. All right. So on that one, all right, here's your equation that you deal with. Since it's draining, it's going to be subtracting 80 liters minus the volume that you have, and you're going to be divided by 2.5. So for this first one, you went from 80 to 75, so that's 5 liters that you drain. 2.5 liters per minute, it's 2 minutes. You went from 80 down to 32.5, so you drained 47.5 liters. Divide that by 2.5 liters per minute, end up with 19 meters. If you went from 80 down to 18, all right, that means 80 minus 18 is 62, divided by 2.5, 24.8 minutes. So just shy of 25 minutes to get to that point. And then there's your overall equation that you have right there. Solve for time. And chapter 8, lesson 8 summary. A little bit of geometry to go through. All right. So you're starting out here. You have what's known as an isosceles triangle. All right. So since this and this are the same angles, all right, you can go and do a lot of information around here. Realize that the two angles near the horizontal have equal measurements. A, the sum of the angles. Now remember, this is the sum of the interior angles of a two-dimensional triangle is 180 degrees. So we'll make sure that we kind of preface that so we're all on the same page. So the relationship, if you add A plus B, you get 180 degrees. All right. Suppose we want to find A when B is 20 degrees. So we're just going to put in a 20 right here. A plus A, you can add those together because they're like terms, so that's 2A. So here's your equation right here. I'm solving for A, and so I subtract the 20 from both sides. I get 160, and then A just turns out, and you divide both sides by 2, and A turns out to be 80 degrees. And you can always check your work. You can say, okay, 80 plus 80 plus 20. 80 and 80 is 160. 160 plus 20 is 180. So yeah, always check your work. What's the value for A if B is 45? Same idea. I'm just going to put in 45 here. Subtract it from both sides. Now 2A is equal to 135, so A is 67.5 degrees. Suppose the two bottom angles are 34 apiece. Now I'm substituting in for the A's, and I got to solve for B. So 34 plus B is 180. So you add the 34s, you get 68. Subtract 68 from each side. And you end up with B being 112. All right, so it's a 34, 112. And find the value for B if A is 72.5. So 72.5 plus B is 180. You add these two and you get 145. Subtract 145 from each side. And B turns out to be 35 degrees. Instead of taking these steps over and over, we know B and we want to find A, we can rearrange to isolate for A. So here, they're kind of doing what we did before. They're taking this equation and they're solving for the value of A. So we're going to go and put B on the other side using subtraction, and then going to divide by 2, 2 being the coefficient of the unknown. And so you get this equation right here. Right? If you wanted to solve for B, you'd take your root equation, combine like terms, subtract 2A from each side, and then B is all by itself. You solve for B. Right? And that's it for the summary for the lesson. Thank you for your time.